Okay, so today I'm going to be talking about the power of pixels. So just a quick rundown of what I'm going to be going through. And let's start with introduction. So what is a pixel? So a pixel is the smallest unit of a digital image and forms the foundation of all digital graphics, from photos and videos to games and apps. They do not have a fixed size, but rather scale up and down depending on the size of the screen and the pixel density. So brief history of pixel-based graphics. In 1965 was the birth of the first digital image of around 176 by 176 pixels and was created by a man named Russell Kirsch. In 1972, we saw the release of Pong, the most significant game to be made, as Pong laid the groundwork for the video game industry. In 1983, we saw the creation of the GIF. The GIF format is created by CompuServe, and GIFs marked a significant step in digital image processing and compression. Lastly, in 2012, the Retina display was introduced with the iPhone 4 and features a pixel density so high that the human eye cannot discern between individual pixels. But where are we now? So currently, the highest consumer displays available are 8K displays of around 33 million pixels. Real-time ray tracing has also made a prevalent leap in video games, allowing for more accurate light calculations and shadow calculations. High dynamic range, or HDR, captures and displays have also become consumer grade, allowing for more vivid and better-looking realistic images on your screens. And lastly, sub-pixel rendering, which renders the different channels, red, green, and blue individually, allows for more smoother-looking images. The impact on hardware, however, increased exponentially. Budget PCs would buckle under the demand of modern games, whilst consoles remained locked at 30 FPS. Consumers had to ask themselves whether they prefer performance or quality. So looking at performance versus quality. With performance, we have games running smoothly at around 60 frames per second. However, textures are pixelated, accurate lighting, or less accurate lighting and shadows, and overall looks kind of scary. Secondly, quality is everything 4K, max settings. Games looks much better, but unfortunately does not run as smooth, and PC might be under a lot more stress. But what if consumers wanted both? Is there a solution to this problem? And the answer is yes. And that solution is the solution to everything, AI. Specifically, DLSS, or Deep Learning Super Sampling, created by NVIDIA, which leverages machine learning to upscale images from lower resolutions to higher resolutions. This takes the pressure off of the hardware, as modern GPUs are designed specifically with tensor cores to allow for machine learning algorithms to operate faster than rendering would occur. But how does DLSS work? It makes use of a convolutional autoencoder. An autoencoder consists of an encoder and a decoder. The encoder works to take in an image and reduce its resolution and extract important features from the image. The decoder then takes the low resolution image and generates a new upscaled version of the image. The model is trained using 1080p images and 16K images. The 16K image is then used as the ground truth of the model. A 1080p image is sent through the model, and a 4K image is generated out of it, which is compared to the 16K image. A comparison then puts into a loss function, and that loss is propagated back through the network to upgrade the weights and improve the quality of the images generated. This allows for better quality images all running in real time. So example, imagine we had a frame rendered at 4K at max settings that takes around 40 milliseconds to render. This will average around 25 frames per second. A single frame at 1080p, which is 4 times less pixels, would be 4 times faster to render and average around 10 milliseconds and 100 frames per second. This, combined with DLSS to upscale the 1080p results to 4K, results in a 4K frame running or rendering in a quarter of the time. But where can this be used outside of games? So AI upscaling can be used to enhance satellite images, vital for agriculture, environmental modeling, urban planning, and disaster response. It can also be used in cultural heritage preservation to restore art, manuscripts, and other cultural heritage items, allowing for viewers to view details of artifacts that would have otherwise been lost. It can be used in medical imaging to upscale MRIs, CT scans, and X-rays to enhance image clarity, thus improving diagnostic results and eliminating the need for multiple scans, which reduces radiation exposure and medical expenses. Lastly, they can be used to enhance CCTV footage to help identify faces and license plates of criminals. So for my demo, I use a model called ESR-GAN, which is an enhanced super resolution generative adversarial network. So how an adversarial network works is that it contains a generator, which essentially upscales an image, and a discriminator, which predicts whether the image is generated or real. These two networks work in opposition to each other to improve each other. So the first image I tested was just of myself to test whether the model can handle upscaling faces. So the image on the left was around 200 by 200 pixels, and the model improved it by eightfold. So this is around 1080p. And we can see that the image does look much clearer, opposed to some extra artifacts added around the eyes due to the deeper shadows. Next, I tested the image with content. So this is a clip from the first season of The Simpsons, released in around 1980. And with this, we can see how the model can be used to enhance content or to remaster old content, which can be used to allow people to rewatch or enjoy old shows and series in a more modern digital format. Next, I use the model to enhance the image of a brain scan. We can see the model on the right clearly has a lot more detail, which can improve diagnostic results and help doctors identify malignant tumors. And lastly, I use the model to enhance a satellite or aerial view of an agricultural site. We can see the image on the right shows a lot more detail in the agricultural site, which can be used by farmers as well as urban planners. So that's all. I hope you liked it, and thank you.